Good evening, everyone. My name is Elizabeth Ivory, and I'm the current chair of Northumberland Learning Connection. Welcome to our second event in the series Space, Light Years and Dark Matter. Tonight, we have the pleasure of presenting Bob McDonald. Bob is the host of CBC Radio's award-winning weekly science program, Quirks and Quarks. He is also a science commentator for CBC News Network and CBC TV's The National. Bob may not be a scientist, but he has an asteroid named after him, and he has the ability to get people interested in complex topics using everyday language. For that, he has received 13 honorary degrees and is an officer of the Order of Canada. After Bob speaks to us, I'll come back and help with the question and answers. If you've listened to Quirks and Quarks, you'll know that Bob is a master at asking questions of scientists. Tonight, we have our chance to ask him anything we want. So without further ado, I'd ask Bob to turn on his mic and his camera, and he can start presenting.
All right. Hello, Elizabeth. Thank you very much for the kind words, and hello, everyone in Northumberland. Sorry I can't be there. Okay. Has spotlighted your video. Good. Sorry I can't be there. I now live in Victoria, British Columbia on Vancouver Island. I spent most of my life in the Southern Ontario, Toronto area. But in 2011, I just decided I wanted to live in a beautiful place, more beautiful, well, different beautiful. And so I've been living here ever since. So sorry I can't be there in person. I want to talk to you tonight about my perspectives on the Earth that I have gained from more than 50 years of science journalism, science communication, being sort of a jack of all trades, but master of none. I've talked to every kind of scientist there is, not just in space, but in biology and medicine and physics and all of that. And overall, it's given me sort of an overview perspective on our planet and our place in the universe. And so that's what I want to talk to you tonight. But I also want to talk to you about my latest book that Elizabeth mentioned in the slideshow there, Just Say Yes. Now, let me just see if I can share my screen here, and we'll get ourselves underway with my slides. And just bear with me for 1 second. I'm a bit of a Luddite when it comes to this, but let's see if this works from the beginning. Okay, something is telling me I can't do something here. All right, there we are. You got that? Ha, good. So yes, I do want to give you perspectives on the planet, and I'm going to segue into that out of talking about my other book. This book, Just Say Yes, has only been out for a few weeks, and it's already on the British Columbia bestseller list. And I'm getting a very good response from this. And the reason that I wrote this book, it's a memoir, is because people kept asking me, what's your background? How did you get to host Quirks and Quarks? Where did you get your PhD? Where did you go to university and all this? And when I tell people that I'm actually a university dropout and former construction worker, they go, what? So how did that happen? And so I've been asked that so many times, I thought I would write it down. So if you want to know my story, with lots of wonderful anecdotes about sailing and motorcycle and adventures in space, this is where you'll find it. It's in all the bookstores right now. You can get it on Amazon. You can order it online. So this is it. And just to give you a sense, I take my story right back to the very beginning, where I grew up in the town of Orillia, not too far from you, just at the top end of Lake Simcoe on Lake Couchiching, the beginning of cottage country. Now, if you Google me, it'll say that I was born in Wingham, Ontario, which is true. My family lived just north of that small town of Teeswater. Wingham had the hospital, but as soon as I was born, they moved to Orillia. So that's why I call it my hometown. And I spent a lot of time in the water in the summertime and a lot of time playing in the snow in the wintertime. But if you were to go back more than 60 years to Orillia and see this kid and tell this kid that one day Orillia would have a banner hanging on its main street with his picture on it, inducting him into the Aurelia Hall of Fame, he would not believe that. If you were to tell him that one day 13 universities would call him doctor, honorary doctorate, he wouldn't believe that either. If you were to tell him that one day the Governor General of Canada would drape a medal around his neck, that's the highest order a civilian can get, he wouldn't believe that either. Because this kid growing up in small town Ontario, here I'm being introduced to a cat by my older brother Leo, we were a low income family. We were not living in poverty, but we were certainly the poor people on the block. My parents were not well educated and they could barely keep food on the table. And we couldn't do what other families did. We couldn't take vacations to Disneyland or even go to restaurants. We got by, but we were living in poverty. And what this living in low income, and what that does to you is it makes you feel like you're not good enough, that you're not worthy, you're not like other people. My mother, Helena, was the exact opposite of a helicopter parent. Her mantra was, get out of the house. Don't bother me. Get out of the house. And it didn't matter if it was winter or summer. She just didn't want us around the house. And she did that to all of us. I have 3 siblings. I have 2 older sisters and an older brother. They are all within 2 years of each other. Then 7 years went by and I came along. So maybe that was why they left town. I don't know. But I'm the youngest of the family. So that's why I spent a lot of time outside and still do. And I spent a lot of time alone outside, but also with friends. But that was her mantra, just get out and don't bother me around the house. My dad, Clifford, here he is with my brother. He could look very dapper on Sunday. We were raised Catholic, had to go to church all the time, not just Sunday, but all the holy days and all that stuff. And he was very charming on Sunday. Unfortunately, during the rest of the week, he was a serious alcoholic, which is the main reason that we didn't have much of an income. And he was a violent alcoholic, an abusive alcoholic. So home for me was not a comfortable place. It was not a place I liked coming home to because I didn't know whether I was going to meet Dr. Jekyll or Mr. Hyde. And very often it was Mr. Hyde. So this was my upbringing. So this kid grew up believing that he's not good enough in an abusive alcoholic home. That alcohol, by the way, took my dad's life at age 55. He just literally drank himself to death. So that's the background that I come from. But there were some interesting things that happened while I was a kid. We didn't have a lot of books in the house, but my mother did bring this one home, and I still have it. This is just called The Planets. It's the Golden Library of Knowledge, and it's an illustrated book. I got this when I think I was 8 years old, and it's just drawings of the solar system. And I noticed one of your other speakers is going to take you through the solar system. But one of the images that really got me in this book was this one. And it's an image of Jupiter, a drawing of Jupiter. This is before the space program. This is before we had robots going out to all these planets and taking pictures. It's all just what we saw on telescopes. So these are artists' impressions of what they thought Jupiter would look like. And the caption here really got me. It said, seen from Amalthea, Jupiter's closest moon, Jupiter would fill 1/4 of your sky. And I thought about this. So that this is real. This isn't science fiction. And I was old enough to know fractions. And I thought, okay, if that's your whole sky and that's half your sky, that's 1/4 of the sky, that would be really big in the sky. And I did a little experiment, actually, believe it or not. The next time I saw the full moon, I measured it. And I dare you to do this. How big do you think the moon is? I know sometimes when it's low on the horizon, it looks gigantic. But if you put your arm straight out and measure the moon, it is the size of an aspirin. That's how big our moon is. So our moon is this big and it looks great. Imagine something gigantic in the sky, swirling clouds. I read about Jupiter, it's all storms, all that. So that was pretty amazing. So as a kid, I knew about all the planets in the solar system. So space already got me. Space got me. And it was like, wow, there are all these other worlds out there that are the Earth's brothers and sisters, the Earth's family, but they're all really, really different. Saturn's got rings around it. Mars might have life on it. Venus is super hot. They're all different. So as a kid, already had a sense of the Earth's place in space and even the fact that we lived in a galaxy. I knew that as a kid. The other thing that happened later on, when I was 18, we landed on the moon. And I got to show you something because I just got this. I gave a talk in Burlington just last week, and as a gift, I can't believe what they gave me. Look at this. This is an original Toronto telegram from July 20th, 1969, showing that we landed on the moon. This is unbelievable. I don't know how I'm going to preserve this because it smells kind of moldy, but this is the whole newspaper. An original, we landed on the moon. Isn't that incredible? So that's quite a gift. But I watched that. I watched that. And I watched not only that, all of the moon landings, all 6 of them. I watched them all because I was totally captivated by that. I knew the names of all the astronauts right from the beginning. I even remember Sputnik, the very first satellite, which means the whole space program has happened within my lifetime. I've watched us go from not knowing what things were like out there to actually going out there. This has all happened within my lifetime. And it was very exciting. So those are the things that I saw as a kid. But when I did go to university, I dropped out after second year and I took a job building these things because I figured that's what my class of people do. I was interested in science, but I wasn't good at doing science. I'm terrible at math. I can't do chemistry very well, but I was fascinated by what science was doing. We were going to the moon, maybe Mars. There were all these new products coming out like Teflon and Tang and all that stuff, and microwave ovens, whatever. But I just wasn't good at it. So I failed second year university, dropped out, and I worked construction. But then a big change came, and it was the first time that I said yes. And in 1973, my girlfriend at the time told me that the Ontario Science Center was looking for people to do demonstrations, stand hair up on end with static electricity, burn holes through fire bricks with a giant laser, freeze flowers in liquid nitrogen in a couple of seconds. And that I'd be good at that because I had done some theater when I was in school. And so I did. So I took some time off the company time and I drove my truck to the Science Center. And I met the guy who was hiring. And I just talked his ear off. I don't even know what I said. I said, I'd love to work here. This combines my love of theater and science together. It'd be great. This is a wonderful institution. I'd really like to work here, blah, 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 blah. And he just stopped me at one point and he said, you're the kind of person we'd like to have here. And he hired me on the spot on enthusiasm. So that was amazing. That was a huge change in my life. I went from having a blue shirt with my name on the breast here to wearing a white lab coat, wowing people with science. And later on, this is sort of what I look like. Don't laugh. I know you've all got pictures like this somewhere in a drawer or in an album somewhere, but this this is what I looked like. I was in the education department, and it's my Mick Jagger look, I guess. But at the same time, the media would call up when things were happening in space. Would you come on and talk about this thing that landed on Mars? And okay, I could do that. I'd never been on television. So I said, okay. And I went on television in 1976 when Viking landed on Mars. First one with color pictures, first one with experiments to look for life. And I got really excited. I said, oh yeah, here's what happened. Here are the pictures. This is really great. Blah, blah, blah. I was on the news. And after the news was over, and I was just getting off the set, or after my interview was over, taking the microphone off, the director came down from the control room, stood right in front of me with her hands on her hips. And she pointed at me and she said, you're really good on camera. If you want to come back, we'll have you to do more science. I went, okay. I'm still doing it today. They still call me, can you come on tonight and talk about something? Oh, okay, I'll do that. And the next day, CTV called up and asked me to go on the morning show. And they said the same thing. Global asked me, they said, so suddenly I'm appearing on all these different or television programs, television networks. So word got out that there's this guy who can talk science, can be funny, has visuals and demonstrations. And that started my media career as well. Now, I wanted to follow space missions because I was so interested in them. And in 1977, there was a mission that was going out to Jupiter, Saturn, Uranus, and Neptune called Voyager. And it was being launched from Cape Canaveral. So I got on my motorcycle and I rode to Cape Canaveral from Toronto. And then I saw this launch of Voyager. And I saw it with Dr. Carl Sagan, famous astronomer, who he and a group of people had put a golden record on Voyager as a message to anyone out there who might find it, because Voyager was only the third spacecraft we'd ever sent that will escape the sun and wander among the stars of the Milky Way galaxy for billions of years. And it was quite an emotional time because after the rocket took off and it was gone and out of sight, Sagan turned around, he had tears in his eyes and he said, "We just sent a spaceship to the stars." And it was profound. All of us were thinking about that this object is going to be out there for more than 1 billion years. We've never made anything last that long that humans have made. You know, the oldest stone tools that we have from our ancestors are about 2 million years old. This thing's going to be, 1,000 times more than that. So it's unbelievable. And as we were driving back, we thought about the fact that civilization could completely disappear. The continents of the earth are going to shift. Ice ages could come and go. The earth is going to change, and that thing will still be out there for 1 billion years. So it was quite a profound moment. Then 3 years later, 2 years later, when it got to Jupiter, I went to the Jet Propulsion Lab in California to watch the pictures come down. And finally, I got to see Jupiter close up. So I went from the drawing in this book to actually seeing Jupiter for real. And it has been an exquisite pleasure to be a journalist during the time when we've actually gone out to all of these planets and visited them for real. And we've been to every planet in the solar system, and I've been there when these pictures first come down. I've sort of made it my mission in life. I think of it like being a crew member on Magellan's ship. Magellan tried sailing around the world, and every now and then they'd come upon an island or a new land, and the crow's nest, the lookout up in the crow's nest would holler, "Land ho!" And everybody runs to the railing and you go, "Oh, look at that, new land." That's what we were doing. We were seeing new land, but it was entirely alien. These were entirely alien worlds that we were seeing. So it was an incredible journey of pure discovery. And you only go to some place for the first time once. And I feel very fortunate that I was part of that. And it was a very level playing field. The scientists and the journalists, we were all in the same plane because we were seeing things for the very first time and going, "Wow, look at that. Look at that. What do you think that is?" "I don't know yet. Let's find out." So it was really quite exciting. I also got to meet interesting people besides the scientists who run the robots. I've met several people who've been in space, including all our Canadian astronauts. But a really special one was the guy in the white T-shirt here, not the guy having a bad hair day in the middle. And that is Buzz Aldrin from Apollo 11, the one that I just showed you a picture of standing on the moon. And this was a wonderful opportunity. When I was living in Toronto, I helped organize a conference on going back to the moon, and Buzz was the guest of honor. So they sat me beside him at the banquet at dinner, and I just threw it out. I said, "Hey, Buzz, I have a sailboat in Toronto Harbor. Would you like to go for a sail tomorrow? Off the record, no cameras, nothing, just go for a sail?" And he said, "Yes." I took Buzz Aldrin sailing. It was amazing. And he said something very interesting. He said, "The moon is a really interesting place, but it's not a very nice place." And he's right. The moon will kill you. Buzz is one of only 24 human beings to see this, to see the Earth from another world. And if you look at this picture, the contrast is incredible. In the foreground at the bottom is the surface of the moon. It's dry, it's airless, it's desolate, it'll kill you. You have to wear a spacesuit on Mars because it's a vacuum. Standing on the moon is the equivalent of floating in empty space. You're in empty space. You're subject to radiation from the sun. You got to carry your oxygen with you. You have to have a cooling system to keep your body at a right temperature. So the moon will kill you if you don't wear a spacesuit. And there's our beautiful oasis of an Earth, all multicolored and not very big. from the moon, the Earth disappears behind your thumb. So from the Earth, the moon is the size of an aspirin with your hand straight up, but from the moon, you can hide it behind your thumb, which is pretty astounding. And what do you see around it? Black. The blackness of the universe that will kill you. The universe is deadly. And here's this beautiful little blue marble. And it's no coincidence to me that right after the first picture of this, and by the way, I met the guy who took the very first Earthrise picture. His name was Bill Anders. He didn't land on the moon, but he was on the very first mission to go there, Apollo 8. So they went to the moon and they just went around it a few times and then came home to prove that we could do it. But it was the first time humans left the Earth entirely. They don't get this view today on the International Space Station because they're too close to the Earth. They're only 400 kilometers up. And that's not very high. That's like, what, Cobourg to Montreal? Something like that. And so they can see the curve of the Earth, but they don't see the whole planet. You got to go halfway to the moon before you can see the whole Earth. So it was only the Apollo astronauts that saw that. And I had breakfast with Bill Anders one time. And again, it was one of these informal things. It was quite neat. And I asked him about taking this picture. And he said, you know, that was not on our schedule. That was not part of our itinerary. We were there to map the moon. We were to photograph the landing sites so that they would have high resolution pictures when they landed and they'd know where to touch down. He said it was on our third time around the moon and the capsule just happened to be pointed forward and the Earth came up over the horizon. And it was like, holy crap, look at that. Quick, get a picture, you know, click. Oh yeah, click, took the picture. But right after this picture was taken, Earth Day came along, the Environmental Protection Agency came along in the US, Environment Canada started in Canada. We turned ourselves back towards our home. We realized that that's it. It's everything we know is there in that little ball. That, along with Rachel Carson's book, Silent Spring, really started the environmental movement when we finally got ourselves out on a perspective where we could see the whole thing at once. Our next Canadian to fly in space, Jeremy Hansen, he's getting ready to go to the moon. He won't land, but he'll go even farther than the Apollo astronauts did on the Artemis 2 mission. They sent up an Artemis 1, which is the capsule he's going to fly in, but with no one in it. And it took this picture looking back. And if you look in the upper right there, you can see both the Earth and the moon in the same frame. So Jeremy's going beyond the moon. He's going to go deeper into space than humans have ever gone. And he'll be the first, among the first humans to see both the Earth and the moon in the same shot. And they'll be even smaller. You can probably hide those behind your little finger or less. So we're getting a perspective on ourselves. We're getting a perspective on ourselves as a little double planet. Well, we're also getting perspectives on other planets thanks to the robots that are there. We've got 2 cars that are driving around on Mars right now. One of them's called Curiosity. The other one's called Perseverance. We even had a helicopter there for a while until it crashed. So we're exploring these other worlds, and they're showing us that they're very, very different from Earth. On Mars, the sky is pink. It's not blue. And that's because there's a lot of dust in it and there isn't a lot of air. And the air that they do have is mostly carbon dioxide. There's no oxygen. So, in other words, Mars will kill you. We will send people there. It's the only planet in our solar system we can visit, but they'll have to wear spacesuits all the time. They'll have to live under domes or probably underground because there's no ozone layer there to stop solar radiation getting through to the surface. So it's a very deadly, cold, dry place. It seldom gets above 0. The average temperature is about -20 during the day, which for Canadians isn't too bad. But at night, it goes down to about -90. So even Canadians will shiver at that. So we're seeing that Mars is an interesting place, but not a very nice place. not a very friendly place. But we know that this hasn't always been the case. We know from markings that Mars used to be wet. This is the landing site of the second one, the Perseverance rover. And you can see that it looks like a river delta. And that's because it was a river delta. And so water flowed on Mars, and it flowed long enough and hard enough to move dirt around and make deltas like this. And we're exploring that delta right now. That's the route that Perseverance is going to follow. They're going to go up and take some samples of that delta and try to get a sense of the history of Mars. And Curiosity, in its landing spot, it landed in a crater and has already proven that that crater used to be a lake. So Mars in the past had lakes and rivers. Some people think maybe even an ocean. So it was warm in the past. And it has layers just like we do in its rocks. So we're studying those layers and putting together the history of Mars climate. And what we found is that according to one model, Mars used to have an ocean that covered its northern hemisphere and a big sea in the southern hemisphere about the size of the Mediterranean. Mars is small. It's only about half the size of the Earth, but it has huge features on it. On the left side there, you can see those 5 big dots. Those are volcanoes. And some of them are larger than any volcanoes we have here on Earth. One of them is even twice as high as Mount Everest. But something happened. There was a time when you could go swimming on Mars, but it lost its atmosphere. Its volcanoes went quiet, and its atmosphere was burned off into space. And being a small planet, it didn't have enough gravity to hold on to its atmosphere, so it was burned away. So today, the water is frozen underground and in the polar ice caps, and the atmosphere is very thin. It's 1% of the atmosphere that we have here on Earth. So Mars is a really good indication of how planets can change. You talk about climate change. This is severe climate change and going from warm to cold. We know our planet is changing. We're changing our climate, but we're going from cool to warm and even warmer. So planets do this. Planets change a lot. And that's why we need to pay attention to them. That's why we study other planets, is to understand and get a perspective on our own. If you're going to look for life, we thought that Mars was the place to go, you know, little green men and all that. But we found that the surface of Mars is very hostile to life today. We haven't found any signs of it at all. No little green men have walked by our cameras. That'd be really cool if they did. Wouldn't that be neat? Because our landers, our rovers, would be UFOs to them. So you imagine all these Martians with their iPhones going, oh, get a picture of that, get a picture of that. Where'd that come from? That's weird. But we haven't seen that yet. yet. Maybe there's life underground. Maybe there was life on Mars. There might be fossils underground, or maybe there are underground streams or something, but Mars is looking less and less like a place to look for life. However, there are other places in the solar system where we could. And one of them is called Europa. And there's a rocket that was supposed to launch today to go to Europa, but thanks to Hurricane Milton, they've delayed it a little bit, so it'll probably go off next week. Europa is a moon. It's not a planet. It's a moon of Jupiter. And it's about the size of our moon. And when we saw this for the first time, it was very strange because it doesn't have any mountains on it or valleys. It's totally smooth and kind of this whitish cream color. If you could hold it in your hand, it would be as smooth as a cue ball in billiards, the white cue ball. It was like, well, what the heck's that all about? How come it's so smooth and so evenly white? Well, the only explanation is that it's covered in ice. The whole moon is covered in ice. And we have since found that the ice is cracked, it's floating, and they believe that there's an ocean underneath that ice. And the ocean contains as much water, get ready, the ocean contains as much water as the Earth has times 2. It has twice as much water as all of our oceans here on Earth. That's astounding. A little moon of Jupiter has more water than the Earth, twice. And so if you're going to look for life, that's a good spot. But we have to drill through the ice. It's quite thick. The Europa Clipper mission is going to go there, and it's going to determine how thick that ice is, how deep the ocean is, and what Europa is like on the inside, and whether or not there are conditions for life. I think they should send a Canadian there. We do a little ice fishing, you know, drill a hole, drop a line, see what we catch. If we're going to go there, there's another moon going around Saturn that's the same way. It's called Enceladus. It's covered in ice. That ice has cracks in it, and there are ice geysers that are shooting out into space. They're shooting ice crystals out into space because there's a liquid ocean underneath the ice. And we had a spacecraft at Saturn called Cassini that actually flew right through those plumes and sampled them. And it's water ice. It's water ice, but it also contains organic chemicals, carbon-based chemicals that are very similar to the chemicals that we see in the bottom of our oceans. In the depths, some of the deepest parts of our oceans, there are cracks in the ocean floor and hot water comes out. These are hot water springs. The hot water comes out of the sea laden with chemicals, carbon-based chemicals. And there are bacteria that eat those chemicals, that live on them. And then there are other animals that live on the bacteria. And there's a whole food chain in these oases that just live around the vents. There are crabs, there are clams, there are these long things called tube worms, and they're all filter feeders. They all eat the bacteria. So there's a whole ecosystem on its own, independent of the sun, because they live in permanent darkness. It's so deep, the sun doesn't get there. So instead of photosynthesis, they use chemosynthesis, which is vile. So this could be happening inside these moons of Jupiter and Saturn. Isn't that interesting? So this could be the first kind of alien life that we find. It won't be little green men, it'll be worms. Or who knows what, who knows what. Some people even think that this is the way life started on Earth. These were the original forms of life here before it got up on land. Not sure, but it's an interesting idea. So we've got interesting places out there that are harbors of life, but they're nothing like the environments that we have here on Earth, except down in the deep ocean. Even Pluto, even distant Pluto, which we only saw for the first time in 2015. And again, I made a motorcycle trip to go see that encounter in 2015. Pluto is an ice world, and it has ice mountains. These mountains are as tall as our Rockies in British Columbia, as tall as the Rocky Mountains, but they're made of ice. Can you imagine seeing ice mountains that are, 12,000 feet high? It must be beautiful. It must be really beautiful. And there are glaciers there that are made of not just water ice, but nitrogen ice, which is frozen air that are flowing around. And it's now believed that beneath the surface of Pluto, there may be a liquid ocean as well. So water is very common. Water's all over the place, but most of it's covered in ice. Only some of our water here on Earth is covered in ice. There's some of the glaciers that are moving around on the surface of Pluto. It's really quite amazing. We're finding now planets going around other stars. There are over 5,000 that they found going on around other stars. This system is called the TRAPPIST system, and there are 7 planets going around it that we found. And I think it's 3 that are in what's called the habitable zone, the Goldilocks zone. They're not too hot and they're not too cold. They're just the right distance from their star that the temperature is right where you could have liquid water on the surface. And we found a few planets like this that are in that Goldilocks zone. And everybody gets excited. They say, ooh, they're other Earths. They're not other Earths. They may be interesting. They may have water on their surface, but they're not going to be like the Earth. And there's a couple of reasons for that. The stars that these planets orbit are called red dwarfs. And they're not like our sun. They're smaller and they're dimmer. They don't give off as much light or as much heat. And in the same way, when you're camping and you got a campfire going, you get it going at first, it's really blazing, and you can sit back and roast your hot dogs and marshmallows and all that. But then as the fire goes down, turns into embers, you have to get closer to it to keep warm. These planets are huddled in really, really close to their star. So their year, the time it takes them to go around their star, is measured in days, not years like our planets. So they're very, very, very close. And when you have planets really close to a star, they become gravitationally locked, just like our moon is with the Earth. When you look at the moon, you always see the same face because the moon always keeps the same face towards us as it goes around. Well, these planets would do that to their stars. They would always keep one face to their star as they go around it, which means even if they've got water, one side, the sun never sets. The sun would always be in the same position in the sky. So that would be very hot, like the Sahara Desert. The other side would never see the sun, so it would be super cold, exposed to the cold of space, 200 degrees below zero. So it would be frozen like the South Pole of Antarctica. Maybe there would be a band between day and night that might be the right temperature, but I don't know. And I don't know what kind of weather you're going to get on planets like that. So if there's life there, if there's water there, the environment is going to be so different from what we know here on Earth. They're just not going to be like this. We're finding both water and the chemicals of life, the organic chemicals, amino acids that are the base of our DNA. We're seeing that out in space. There's clouds of them out there. So the ingredients for life are floating among the stars. There are frozen worlds with oceans under them that could harbor life. There are planets out there that may have liquid water on their surface. So yeah, it's really interesting, but we have yet to find another one of these. We have yet to find another Earth. We haven't. We're finding all kinds of, we might, but when we do, it's going to be very, very far away from here. So far away that we can't even talk to it. It takes time for a radio signal to travel through space. Even when we want to talk to our rovers on Mars, there's a time delay of up to 20 minutes because of the distance between Earth and Mars, 20 minutes each way. So if you have friends who go to Mars and you want to give them a call, you can't. You have to send an email or a voicemail and wait for your signal to get to them to get it, and then send it back again. So 40 minutes just to say, hey, how you doing? Oh, not bad. Took 40 minutes to do that. If you want to talk to planets going around other stars, it takes years each way, hundreds of years in some cases. So more than your lifetime just to say hello. Is anybody there? And if they care to answer, yeah, what do you want? That could take 200 years. So we won't be able to get there. And our rockets are way too slow. We can't send people out there. We're just too slow. It takes 9 years just to get to Pluto. Take more than your lifetime to get to another star, unless we invent warp drive. Yeah. By the way, I love Star Trek, but it always bothers me that every time they go to a planet and they land on the surface, it's always a really nice day. It's not like that. The universe is not like, and all the aliens speak English. Come on, give me a break. It's not like that. The universe is a violent, deadly place. Violent, deadly place. And here we are on this amazing oasis. This is it. This is where we live. And I met the guy who took this picture, this iconic picture that's sort of become the poster child for the environmental movement. His name was Jack Schmidt. He was the only scientist to go to the moon, and he was on the very last mission to the moon, Apollo 17 in 1972. He was also an avid photographer, and they were the only mission that went to the moon that got a full Earth on the way back. And so he snapped the shot and saw the full Earth. And look what's in the middle of the picture, the continent of Africa. And in the middle of Africa, underneath those clouds, are the countries of Tanzania, Kenya, and Ethiopia, where we have found our oldest human ancestors, the Australopithecines. I was in Tanzania just last year, and they have a site there called the Olduvai Gorge, where some of the first of our human relatives were found. One of them was called Homo habilis, handyman. They were among the first tool makers 2 million years ago. And they had actually some stone tools there. And the guy had handed me one. I held it in my hand. And it was just like, I said, it looks like something picked out of a river. And he said, it probably was picked out of a river because it was rounded. But he said, look at the edge and you can see how it's been chipped into a sharp blade. And they use it as a chopping tool to crush bones or smash veggies or get skin off a bone or something. He said, it's a chopping tool. I said, oh, isn't that neat? And then it struck me. This thing fits my hand. And suddenly I realized that I was holding the same tool that someone 2 million years ago used to make dinner. And it was in my hand. I felt like I was shaking hands with a distant relative from 2 million years ago. It was a profound moment. So there, right in the center of this picture, is where we started making tools. And this was the last picture of the whole Earth taken by hand with a Hasselblad camera. Any picture you see of the whole Earth today is taken by satellite. This is the last handheld picture of the whole Earth. Jeremy Hansen will get one of these, but this is the last one. I find that profound, how far we've come in the last 2 million years, from looking up at the sky, wondering what those dots out there were, to actually going there and looking back on ourselves. So let me give you just a little perspective before I close off here on this planet of ours. First of all, it's small. That's the Earth compared to Jupiter. You could put 1,000 Earths inside Jupiter. And most of the planets we're finding going around other stars are like Jupiter. They're not like us. So we're a tiny, tiny planet. We're a rock. Jupiter's made mostly of gas. We're a rock, a little rock. If you cut an apple in half, look at the skin, because the thickness of the skin of an apple is the same scale as the thickness of our atmosphere is to the Earth. The air going around the Earth is just a thin, thin bubble, a really thin bubble. You can almost walk out of it. If you climb our tallest mountain, Mount Everest, you will die if you stay there without oxygen, because you're already above a good part of our atmosphere standing on a mountaintop. In fact, they call it the dead zone up there. We've got tourist flights now that are going up just for a few minutes at a time, sticking their head up above the atmosphere. When William Shatner from Star Trek was taken up, he came down in tears because he saw how thin the band of our atmosphere really is. That all life depends on that, this little tiny bubble, membrane of air. So we don't have a lot of air. We don't have a lot of land. We don't have a lot of air. And we don't have a lot of water. Even though we call ourselves the blue planet, if you took all the water on the Earth and turned into a drop, that's what it would look like. The big drop is the salt water. The little drop is the fresh water. That's it. That's all we have. So here we are. Here we are in this little tiny world. And this is all we have. This is all we have. We can't go hopping among the stars yet because we don't have warp drive or some convenient time travel that'll allow us to get to other worlds. The other worlds that are within reach will all kill us. We live in the Garden of Eden. We live in the Garden of Eden. And that is the perspective that I have gained from 50 years of science journalism, studying other worlds and seeing the true context of planet Earth, the small little wet rock. And I'll just let me get out of my share here. Let me give you a little demonstration. And I invite you to do this with kids, to talk about some things about the Earth. First of all, I got my beautiful model of the Earth. It moves. It moves. So right now, as you sit in Northumberland or Coburg or wherever you are, you, since this time yesterday, have been all the way around the Earth. Let's see if I can find Northumberland here. Okay, here's North America, and you are, there's Lake Ontario. So you're about there. So you're not at the top, you're not in the middle, you're about halfway between the top and the middle. So since this time yesterday, you've been all the way around the world because the Earth took you with it as it turns in 24 hours. That's a long way to go in only 24 hours. So you're moving right now at about 800 kilometers an hour. That's the speed of a jet airliner, just sitting in your chair. That's how fast you're moving around the center of the Earth. If you go to the equator, you're moving at 1,600 kilometers an hour, which is supersonic. So you're traveling the speed of an F-18 jet fighter just lying on a beach in Africa. Then the Earth is going around the sun. So we're moving through space this way. And that's a long way to go every year. So the Earth is moving at 30 kilometers every second. That's 100,000 kilometers an hour, 30 kilometers every second. So what's 30 kilometers? What distance between Coburg and Hope? maybe, maybe a bit more than that. Not much. That's what you do every second. And that's really fast. That's faster than our rockets. So we're whipping around the sun, and then we're whipping around our Milky Way galaxy, this huge city of stars that we live in. It takes 250 million years just to turn once. So the last time we were here, it was before the dinosaurs. But it turns what? But it's so big, we're moving really fast. We're doing 300 kilometers per second around the center of our galaxy. So here we are on this little wet rock racing through space, spinning and roaring along at a tremendous rate, stuck to the surface. And this is all we have. So that's why it's really important that we understand how the Earth works. We understand how the climate works. We understand our influence on it, and we try to engineer our way out of this little situation that we're in right now, where we're changing the climate in negative ways. We know how to do that. And it's going to take some good science education to do that. And I'm going to do my part to try to keep spreading the word about science, about our beautiful blue planet. And I hope that you do too. And I invite you to take young people outside and take them to the woods and push their face in the dirt. Rip the devices out of their hands. Take them away from their gaming computers. Tear them out of the hands of their overprotective helicopter parents and shove their face in the dirt. Make them appreciate this beautiful world we live in. Turn over some rocks and see what's crawling around underneath them. Look at the life that's within the first inch of soil. Look at the trees, how they can take sunlight and turn it into food directly. Watch the clouds go by. Think about this thin atmosphere that we live in and really appreciate this beautiful, beautiful Garden of Eden that we live in. So I'm going to leave it there, if that's okay. And I'm happy to take questions from anyone who wants to ask me anything.
Okay, thank you, Bob. Well, I'm going to help with that. We've got quite a few questions already, and I'm sure more people will ask as you start responding. To do that, please use the Q&A field on the bottom of your screen. Just type it in and I will read it to Bob. Okay, the first question that I'm going to ask is, how do you recommend we respond to and resist science skepticism? People who hear you might say, look what happened to Mars. Isn't that just natural? How can you tell me that it's us that is causing climate change?
Well, first of all, it's good to be skeptical, but believe the science, because climate science has been studying this for a long time. And you're right, Mars goes through natural changes, so does the Earth. We've had 5 ice ages. And when I first started as a journalist, my very first job at the CBC was to do a 1-hour documentary on climate change in 1977. 1977, they were talking about climate. In fact, they were talking about it before that. And back then there was an argument among the climate scientists. The geologists who look way back in time were saying, like, we've had these 5 ice ages, and between the cold periods, there are these warm interglacial periods that last about 10,000 years. Well, it's been 12,000 years since the last ice age, so we should be getting cooler. The climate scientists were saying, yes, that's true, but now there's a new game in town called greenhouse gases, and they're going to override that, and they're going to heat up the atmosphere. Well, we know who won that argument. So yes, we know about all the natural cycles that the Earth goes through, both long and short. Those are in the background. And what the scientists are concerned about is the rate of change, how quickly we're changing things, because we're doing things in decades that used to take millennia, or at least, yeah, used to take millennia. And that's what's worrying. The Earth has been warmer than it is now. When the dinosaurs were here, it was warmer than it is now. But it took time for the change, unless an asteroid hits, then you get a sudden change. So that's the concern. And if you hear anyone who is denying the science, saying, oh, it's wrong, find out who they are. Who's saying that? Are you a climate scientist, or are you someone with an opinion who say, I just don't believe it? Well, it doesn't matter what you believe. Science works on fact. And we have entire departments of universities dedicated to climate science. The United Nations Intergovernmental Panel on Climate Change represents scientists from every part of the world. And they get together, and they've been looking at this now for a long time, and the trend is up. So there's no doubt in the scientific mind that the Earth is warming. The doubt is coming from those who don't want to believe that, and they're putting out misinformation and disinformation, which bothers me a lot. So believe the science. Science is one of the last institutions we have that looks for the truth, and the truth doesn't lie. So let's stick with the science.
Okay, here, maybe this will help. Here's a comment and a question about the Earthrise and pale blue dot photos that you showed. We're currently watching climate change play out. Do we need something like these images now, new images, to make us deal with the current environmental situation?
Sure. And Jeremy Hansen will do that when he goes and sees the Earth and the Moon even smaller than what we saw during the Apollo missions. Sure, it will. But let's also look at the images of the destruction from Hurricane Milton that just went through Florida. Stronger. Back again, when I was in 1977, they were predicting that storms would get stronger. All of the predictions they made are coming true. God, they got 2 storms within 2 weeks. That's unheard of. And that's because the ocean in the Gulf of Mexico is warmer, and that's jet fuel for hurricanes. So they're fueled by warm water from warm oceans caused by a warmer climate. Watch the ice disappear in the Arctic. I've been to the Arctic and I've seen how it's disappearing at a tremendous rate. The same in Greenland. Watch how forest fires, where I live out here in British Columbia, are just burning the whole place up. Wildfires are becoming more common. Climate change is in our face. So look at those images, but don't get depressed, because I did write another book. My last book was called The Future is Now, Solving the Climate Crisis with Today's Technology. And I look at all the ways of generating energy without putting carbon into the atmosphere, like wind and solar and geothermal and tidal and all kinds of crazy ways to generate electricity that already exist. We already know how to do that. We're just not implementing it enough. So we can do that. And I'm actually optimistic that we can engineer our way through this system by just moving ahead and figuring out other ways to generate energy. And that includes using oil and gas. We just burn them in a different way without the carbon emissions. It can all be done.
Oh, there's a question there, but I'll come back to it. What is your take on space tourism? Is it a harmful spectacle or a spotlight on the possibilities of our future?
Well, I'd like a ride, if you don't mind. If you want to sponsor me up there, I'd love to get my head up above the atmosphere, even just for a few minutes. I've been talking about space most of my life and lived space most of my life. I'd love to get up there. And, you know, it's those rockets are so small and they go up for such a short time. They're not really doing much harm compared to the, hundreds of rockets that we're sending up to put up communication satellites and things. But anyone who goes to space is moved by it, and sort of becomes an environmentalist when they come back down because of seeing that thin atmosphere. So I think the more people we can get up there, the better, and we'll have more people who will champion the care of our planet.
Okay. How do you think science-influenced pop culture, movies, and entertainment help pique curiosity and education of young people? From experience, the writer says, my physics teacher, shout out Mr. Anderson, likes to infuse fictional science into classes, and for me, it makes learning physics much more creative. I'm thinking perhaps this is one of our student attendees, which I'm delighted to hear from.
Great to hear that. And I think that's a wonderful idea. Art and science go together very, very well. And you usually get a very beautiful thing. So yeah, I grew up on Star Trek and Star Wars, and it's just fabulous. We need imagination. We need to imagine what other worlds, other cultures would be like, how we'll interact with them. Too bad they're always warlike, but at least Star Trek wasn't always war. It was always trying to get to know them. And a lot of the things that they imagined in Star Trek have come true. Like the communicators became our flip phones and then cell phones. There was also a cartoon series when I was a kid called The Jetsons that showed people talking through video screens. They were talking to each other just like we are right now. And so some of those things, the fiction has actually led to technology and vice versa. And when it comes to some of the fantasy stuff, think about the technology that made the movie, the computer programs that create these 3D images and the sense of motion and how good they are at that now and what that takes to do it. Maybe even want to get a job doing that. And I love teaching physics using everyday objects. I saw one once that was the laws of physics according to Bugs Bunny. And it was one of them was an object traveling in a straight line that goes over a cliff will continue in a straight line in the air until they realize where they are. Then they will stop and drop straight down. The other one was All objects fall at the same speed, except anvils. So I love it. That's great. So mix art and science together. It's wonderful.
But someone wants to know, what is the most surprising insight that an astronaut has shared with you?
There have been a couple. They've all been impressed with the Earth and seeing their hometown when they fly over their hometown and see it in the full context. I've had people who've been in space more than once talk about the changes that they've seen between their flights. Cities have grown, deserts have grown, forests have grown smaller. So the brown areas are getting big and the green areas are getting small. They've seen that. I even had an astronaut say, yeah, it was great to be up there, but I couldn't wait to get home because we're inside a tin can all the time. And I wanted to get out and breathe fresh air again and feel the wind on my face. And they were getting a little claustrophobic up there. Roberta Bondar, our first Canadian woman astronaut, when she went into space, she didn't need to wear glasses because eyeballs go round in space. So when you need glasses because your eyeball is out of shape. But when she got into space in zero gravity, her eyeballs went round, so she didn't need to wear glasses in space. So that was kind of fun. They all like playing with their food, especially liquids, water. It forms balls that'll float around the air. So there's lots of adventures that they have up there, adapting to a world where up and down don't exist. It's really quite fun.
We all loved Chris Hadfield playing his guitar, right? That was
Yep.
a fun Canadian moment. Okay, here's one more. Bob, you mentioned we need to engineer our way out of our current environmental challenges. How do we make sure individuals or countries don't unilaterally do things? Will all people benefit, or will some people or places suffer more than others?
Yeah, it's more than an engineering solution. It's also a social solution, it's an economic solution, and it's a political solution. But I believe that the change is going to come from the ground up. I've already met several people who put solar panels on the roof of their house. They drive an electric car and they charge their car from their house. They drive for free. They drive for free. That's the future. That's the future. And when someone does that, their neighbor is going to say, you're kidding me. You're driving for free. I'm going to do that. Then they put solar panels on. And then the next thing you know, the whole neighborhood has solar panels. And that's how it grows. That's how it grows, by example of people saying, hey, I can do this. I can drive across Canada on an electric car. And I don't worry about range anxiety or whatever. And the new technology comes in. Every time new technology comes around, there's always resistance to it. People say, oh, I like the old ways, like don't change. But eventually they do. I mean, look at telephones. When I was a kid, the phone was on the wall and all it did was talk. Now it's in my pocket and it can do more things. I'm not even aware of how many things this thing can do. That didn't come about because we needed it. It came about because it was a good product and we all liked it. And we all bought into it. And the structure to support it, all the cell towers and satellites, that came about because we like these things. Well, let's like clean energy. It makes sense. It's not only good for the planet, in the long term, it's actually cheaper because the price of gas is not coming down. It keeps going up, right? So do the math. And that's how I think the change is really going to come about. And yes, all of us need to do that. And other countries are doing it more than Canada is. We have a long way to go to catch up.
Okay, here's a big question. I'm going to read the whole thing because some people will have been at the presentation that Katie Mack made last week. We heard Dr. Katie Mack last week, and we heard that the Milky Way was going to experience a collision with Andromeda in 9 billion years, but not to worry because our sun would supernova in 1 billion years and turn us all back into cosmic dust. She's pretty fatalistic and seemed to say that we were unlikely to get far enough away to survive. So what's the point? Do you have any optimism that humanity might develop space travel sufficiently developed to escape the coming catastrophe? After all, we might have come so far, and we have come so far in your lifetime. Who knows what we might discover in the next 1 million lifetimes? Phew.
You're absolutely right. Look what we've done in my lifetime. We've gone from nowhere to the moon and back. And yeah, I think there's a very good chance we could find ways to move out and find other places. Before the sun explodes, it's going to swell up into a red giant that will consume the Earth. It'll be bigger than the orbit of the Earth, but that'll heat Mars up. So maybe all that frozen water that's underground on Mars and the polar caps will melt and it'll become a little more habitable. And then further out, there's a moon of Saturn called Titan that already has a nitrogen atmosphere, and it might warm up, and it's got all the ingredients for life on it too. So maybe we'll just move further away in our solar system and hopefully develop interstellar travel. But in the meantime, that's a long way from now. So let's live where we are. Let's appreciate where we are today and make the most of this, because if we take care of all of our todays, the tomorrows will take care of themselves. And so let's not be fatalistic. Let's not be fatalistic. You think about how short our lives are and how little time we have on this planet. But compared to some insects that only live for a few days, that's their whole life. They live for a matter of days and then they're gone. And they don't get to experience this beautiful planet. Whereas a human can live long enough to travel all over it. One of the best things I ever did in my life when I was in my late 20s, I went all the way around the world by myself. I circled the globe by myself. Took 6 months to do that. Best thing I ever did. And the more you travel, the more you realize there's more to see. So get out there, get off North America, go see how the rest of the world lives and learn about not only planet Earth, but this beautiful country, Canada, that we live in. And appreciate that.
That's inspirational, and your optimism and positive. And I can't talk tonight. Your optimism is great, Bob. After another day of reading about Milton and all the horrible things that are happening all over the world, it's wonderful to focus on the things that are actually wonderful about our
We're
lives
so
and our
fortunate.
planet.
We're so fortunate in Canada. We have opportunities. We can make choices. Nobody's shooting at us. Nobody's bombing us. We're in this wonderful oasis of peace and prosperity. We have resources. We have choices, and it's almost a crime not to take advantage of the choices that we have here in this country.
Okay, just a practical question here. Someone wants to know what you think about carbon pricing. Is that a viable route to curtailing climate change to a degree?
Yes, we need it. And it's bothering me that it's become a political issue.
Mhm.
That it shouldn't be called a tax. It should be called a levy for
Mhm.
those who are polluting to encourage them to cut down on their pollution. And it has worked in many cases. So you have the polluters pay and then use that money towards green technology. What's bothered me about the way it's been working in the past is that what's called the carbon tax just goes into the general fund of the government. Then they decide where they're going to go with green technology. I would like to see a dedicated tax that takes from the polluters and invest it in green energy so that we can stimulate that and get it going. Just like when you buy you pay a license for your car. Well, that pays for the road, right? So that we're all paying for the roads that we can drive on. Well, let's have, at this point, the polluters pay for the green technology so that we can move ahead on that. So I think it is a good thing. And I hope it doesn't become so politicized that we lose it and lose the incentive to get off carbon-based fuels.
Did you ever think of running for public office, Bob?
I've been asked twice. And
3 times now.
yeah, uh, yeah, I've been asked to run for the Green Party twice by Elizabeth May. And on both occasions, I said, thank you very much, Elizabeth, but no. Uh, I think I can reach more people doing what I'm doing now than sitting on Parliament Hill. And so I don't really have any interest in being a politician. I couldn't stand being attacked. I'd take it personally. I think, oh no, don't do that. My insecurity from my childhood would surface again. So no, I think I can reach more people doing radio and television programs and documentaries, writing books, and doing talks
Doing
like
this.
this to try to inspire people and rather than debating in Parliament.
Here's an interesting question. Phil wants to know if you've ever ridden the Vomit Comet, the plane
Yes,
that
I have.
simulates. Okay, tell us about it.
It was a wonderful experience. Um, I've had how much time have we got left? What time is it?
We can go for another 10. Is that okay?
Yeah. Okay. It's a wonderful experience. I was on the commercial one. It's called Zero G that you can buy a ticket on. It's not cheap, but the one I flew is out of Florida, and it's a jet airliner with almost all the seats taken out and just padding around the walls. All the seats are in the back. There are 24 seats in the back, and there are no windows. So you get in this thing and you go through all the things that you do in an airliner. There's even a flight attendant, fasten your seatbelt, put your tray table up and all that stuff. The engines get loud and you just feel the thing moving, but you have no idea what the plane's doing because you can't see out. And then it takes off. You just feel pushed back in your seat. They have a piece of ocean that they're allowed to do these maneuvers in that's 100 nautical miles long and 10,000 feet deep. It's a cube of air. And so they go out there, you get out of your seat and you lie on the floor on your back. And then they put the plane into a steep climb. And because the plane doesn't have any luggage or just enough fuel on it, it's quite light. So they can do that. So they go 45 degrees up, which is a lot. When a jet normally takes off, when you're in a WestJet or Air Canada, you know that moment when it leaves the ground, you go, woo, that's really neat. That's 12 degrees. So this is 45 degrees up. And then they put it into a parabolic arc, which is the natural curve that a baseball or anything you throw in the air follows. And so you rise up off the floor, and for 30 seconds, you're totally weightless. And it's crazy. And everybody's giddy. And when everybody's laughing, they tell you ahead of time, don't swim in the air, because that's your tendency to start swimming. Say, don't swim, because you're just going to kick someone in the head. So the first time you do that, it's just nuts. You're all over the place. And I had a cameraman with me. We were shooting a video. And I'm flying and he's flying. And it was all nuts. 30 seconds later, the plane's pointed 45 degrees down. And so you float back down to the floor and then they pull it up. And you experience 2 Gs, twice your weight as they pull it up. And then they do it again. So we did this 15 times. And after the first couple, you're crazy, but then we got used to it. And I discovered that you just do everything in slow motion. When you move head first, it feels like you're rising up. And if you move feet first, it feels like you're falling down, even though there's no up or down. And at one point, I went into a tuck in the middle of the space, and one of the instructors just spun me around. I went around about 8 times in the middle of the air. And it was, you don't get sick because you're not looking out, and it's your whole body that's floating. And they did 2 other things that were really interesting. They gave us partial Gs because the pilots are flying it. It's this precision flying. And they didn't bring the gravity down to 0. They brought it down to 1/3, which is the gravity of Mars. So I got to see what it's like to walk on Mars. And it's like walking on a trampoline. You're light, but you still have traction. So when we go to Mars, you'll have a different gait. You'll be bouncing along the surface a little lighter. Then they gave us the gravity of the moon, which is 1/6 of a G. And I was amazed how light that really is. When we go to the moon and you're inside a building like this, if you want to go upstairs, you could jump and make it. You could also jump down because you come down slowly. I did a standing backflip. I just stood there and I went completely around in slow motion and landed on my feet. If I tried this here, I'd break every bone in my body. And then I tried a forward flip. I pushed myself off. I used to do gymnastics when I was in school. I tried a forward flip, but I pushed too hard and my back went up and I hit the ceiling of the airplane. And I'm stuck on the ceiling. And I started coming down head first, but I came down slowly. So I just put my hands on the floor and then I pushed myself back up onto my feet again in slow motion. It was fabulous. I loved it. So I recommend it. If you can get a chance to go
What
up
an
on a 0G
experience.
flight, do it.
Wow, well, thank you so much for your patience in answering all these questions. I'm gonna ask one more and then we'll give you a chance to wrap it up. Is there anything you do in your own life for the sake of the planet that you wished everyone else would do too?
Oh, wow. Well, I try to keep a fairly small carbon footprint. I ride a bicycle or walk when I'm in town. I live downtown, so it's very easy, but I did that in Toronto when I lived there too. My bicycle was the best way to get around or public transit. Um, I drive a motorcycle if I'm going long distance, so it gets better mileage than a car. And I have a sailboat that I sail on. And so I try to spend as much time outside as possible. My mother's mantra, get out of the house, still holds. I'm I'm outdoors a lot. I hike. I try to get out into nature. Here in British Columbia, it's really close. Within half an hour, I can be on an ocean beach with nobody on it. I can be in a coastal rainforest with nobody around in half an hour, or sailing among islands with bald eagles on the top. So I just spend as much time appreciating this earth as much as I can. And if we all do that, just get a good dose in nature, get away from what you're doing right now, looking at a computer. Get outside, get
Wow.
out of the house.
Well, on that note, here in Northumberland County, we're supposed to be able to see the aurora really well tonight.
Yes.
So I'm not sure how many of us are going to want to stay up
Yep.
and check that out, but
And
that's a
there's also a
wonderful
comet.
opportunity to be outside.
Yeah, and there's also a comet that's going to be visible just after sunset in the same direction as the sun sets, just above the horizon. It should be visible over the next week or so. So keep an eye out for that.
Okay. Well, somebody said, is there a way that we can applaud all of us watching on Zoom to tell Bob how much we appreciate it and how much we've enjoyed the information, the optimism, the whole package was such a wonderful evening. Bob, thank you so much for sharing that with us. And it was just a fantastic way to continue on our studies about space, reminding us how precious our planet is and what we need to do, or as much as we can, to preserve that. So I'm just going to let our audience know that the next event will be on October 20th, which is the film Wilfred Buck. It's a story about Indigenous astronomer and his experiences growing up and looking up. So that's at the Rainbow Cinema in Coburg on the 20th. That's Sunday afternoon at 3 o'clock. So we hope that as many of you as possible can get out to see that film. And then, of course, we have a number of other speakers coming on Thursdays and one Tuesday. So the schedule is pretty well known by now. I won't go over it, but I want to say again, Bob, thank you so much and wish you all the
Very welcome.
best. I hope you
Thank
get
you.
another chance to defy gravity. And everyone else, before you leave, could you spend 30 seconds answering our survey? That would be really helpful for NLC, and have a very good evening and get
Okay,
outside,
great.
right?
That's right. Thank you very
Thank you,
much,
Bob.
everyone. Thanks a lot. Okay, bye-bye.